Welcome back to Kiersti's virtual classroom. Today we are talking about mining impacts on the environment. Okay, so in this lecture you should start to understand different mining methods, the impacts of mining, how we can reclaim mining areas and the policies behind it, and then how we can have a sustainable use of the minerals that we extract from these mining operations. Okay, so if we think about this one case study that I'm going to present, this is mining for basically cell phones. So cell phones and other high-tech products contain something called tantalum. And this is been really big since about 1998, when there was basically a war on Congo to try to extract this tantalum for use in high-tech technology. So soldiers were controlled the mining operations, and they forced farmers and others to work while taking most of the ore. So they kind of got free labor out of it, and it was kind of a big issue for the residents of Congo, and people entered national parks, killing the wildlife, clearing rainforests, causing a huge havoc on the ecology in the area. And the profits from the coltan sales financed the war. So most tantalum from Congo goes to China. Surprise, surprise. So the point here is that although we can mine these things, we can mine different minerals out of the ores in rocks, it's not necessarily an environmentally friendly process. And in today's standards, as far as in the United States and specifically in California, the standards for environmental protection are so high that there's a limited amount of mining that occurs compared to in 1998, especially in Africa. Africa does not have a lot of regulations, and thus forests kind of get bombarded by these big bad guys that want to come in and just make a buck, and then the environment and the people are all left in a disarray. So today there's a lot more things in place to kind of try to protect those processes, but we'll talk about some of the different things that happen. So in order to figure out what minerals we can extract, what we can use them for, and where we can extract them from, we need to know something about the geology of an area first. So all of our raw materials come from beneath the planet's surface. So we turn all of those raw minerals into products that you use every day. So if you don't know what geology is, it's the study of the Earth's physical features, processes, and history. So this includes things like earthquakes, faults, volcanoes, plate tectonics, rocks and minerals, landslides. Anything that happens to the Earth is considered geology. So our planet consists of many layers, and a lot of these layers will contain particular minerals that we might be interested in, and we might want to use them to make something. Okay, so looking at mineral resources, just in a room, there are thousands or hundreds of minerals being used in particular products. For example, there is gypsum in platen and wallboard. So in all of your walls in your home, you will have gypsum in them. There used to be things like asbestos in the home, but that has proven to be cancerous or cancer-bearing, so that is no longer used in the home. There will be iron or chromium, nickel, anything that's steel-bearing. You might see, if your table's made out of wood, that was, in an essence, mined. Silver and gold jewelry. There's titanium, iron in cosmetics. There's a lot of things. I mean, you can read this diagram here to get an idea of what types of things might be mined and then actually put into the products that you use or the home that you're in. So we use the mined materials extensively. We use it from you know, the stuff in your home, to your garbage cans outside, to the cell phones that you're using. So a child born in 2009 will use approximately 2.9 million pounds of mined resources over its life. So that is one child. And there are 7.8 billion people on this planet. So you can do the extrapolated math. That's a lot of mined resources, right? The average American uses 37,000 pounds of new minerals and fuels every year. That's a lot. There's 340 million Americans. That is a lot of mineral usage, right? So this level of consumption shows the potential for recycling and reuse. So if you don't already, recycle, recycle, recycle. If you learned anything from this class, it is to recycle and be more environmentally conscious. All right, so we obtain these minerals from mining. So mining, in a broad sense, is the extraction of any non-renewable resource. This could be fossil fuels, groundwater, or minerals. So we've talked about fossil fuels, and then groundwater will be next, but right now we're talking a little bit more on the mineral side. So in relation to a mineral, it is the systematic removal of rock, soil, or other material. So we only remove minerals that are of economic interest. So if they do not meet a certain economic potential, if that makes sense, they are not mined. So it has to be worth the mining before the mining operations can be carried out. So because a lot of minerals occur in low concentrations, the concentrated sources must be found before mining happens. So a geologist will go out and try to find these reserves or these areas that have a very concentrated source of whatever mineral they're looking for, and then they will begin the mining. So we extract minerals from something called an ore. So a metal is an element that is lustrous, opaque, and malleable and can conduct heat and electricity. An ore is a mineral of or grouping of minerals from which we extract the metals. So an ore would be found in a rock, and from that ore we can extract things like copper, iron, lead, gold, aluminum. So here we have a tantalite ore, which would be mined and then processed into tantalum and then used in electronics. So we process metals after mining the ore. So most minerals must be processed. Like you saw in this picture here, the ore can't be used as is. It has to be processed and purified, and then used in electronics. So after the ore is mined, we typically crush the rock, and the metals are isolated by chemical and physical means. So the material is processed to purify that metal and get rid of all of the things that we aren't going to actually use. An alloy is a metal that is mixed, melted, or fused with another metal or non-metal substance. So when you see things like steel, that is an alloy of iron and carbon. Okay. Smelting is a procedure where we heat the ore beyond its melting point and then combine it with other metals and chemicals. So this modifies the strength, the malleability of the metals. So we can make things stronger, we can make things weaker if we want. That's what smelting would do. So the environmental cost of processing minerals is pretty large. So most methods are water and energy insensitive. So we use a high amount of water and a high amount of energy to extract and process these metals in order to use them in products. So chemical reactions and heating to extract the metals from ores, they emit air pollution and toxic waste. And then we have things like tailings, which I feel like don't get enough attention because tailings piles can be a huge issue because they're basically just leftover material after this whole process takes place and you've purified the metals. Now these oftentimes on a mine site will just sit. There's a lot more regulations in the United States and California, but prior to that, the tailings piles would kind of just sit. They're just junk piles, and they didn't have any use for them. So they would sit and pollute the soil and water, and they usually contain heavy metals and chemicals from these processes. And then we have surface impoundments, which are kind of like slurries of tailings. So a lot of these contain water, which is even more of an issue because with water, it's a vehicle for that to contaminate more soil and to contaminate more water. And usually they can basically burst these impoundments or these kind of areas where they keep the tailings kind of collected, and they can release pollutants into the environment, and that can be devastating. So we also mine non-metallic minerals and fuels. So sand and gravel is huge in the Central Valley because we have things like the San Joaquin River and the Kings River and the Kern River, and all of those produce a lot of sand and gravel. And there are very large mining operations along those rivers to mine out river rock, to mine out sand, to mine out any kind of gravel used in construction, used in landscaping. If you ever been to Clovis Stone, a lot of their stuff comes from the Kings River. If you've ever driven out 180, they've kind of bypassed it now with the new highway. But if you go down the old 180 on your way to like Centerville, Reedley area, you've probably driven by Vulcan Materials, and they are mining on the Kings River right there. And they mine construction materials that they use in concrete. So it's not just limited to things like metals and diamonds and stuff like that. Okay. And then we have phosphates that are mined for things like fertilizer. We mine limestone, salt, potash, blood diamonds are mined and sold. What else do we have? We have substances for fuel. So uranium is used in nuclear power. We talked about this last week with coal, petroleum, natural gas, oil sands, oil shale, all of those petroleum-based natural gas, natural coal processes. These are all organic, but they are mined. So they're part of this mining process, and they do have impacts on the environment. So in different areas of the world, we will see different things, particularly mined. We mine a lot of different things in the United States, but we're most known for zinc, and that is used for things like auto parts, batteries, paints. That it's also from China. China, you'll notice on here, produces a lot of different main mineral resources. And that's because they have a very diverse geology, so they don't have as many regulations as a lot of other areas. So you'll see a lot more mineral resources come out of China than pretty much anywhere else in the world. But this kind of gives you an idea of where a lot of the big hitters come from, as far as the mineral resources that we would use and kind of what we would use them for. So their mining methods, not just the mining process, but the methods that particular miners will use will have different impacts. So depending on the type of mining you'll see a different impact, right? So you won't have tailings piles that have high concentration of heavy metals that could contaminate soil and groundwater in a Vulcan material where they are extracting sand and gravel. Their likelihood of contaminating things with heavy metals is much less likely because of their mining methods and what they are mining. So mining is good because it provides a lot of jobs and money for communities, and it provides a lot of the raw materials for the products that we use, but it does have environmental and social costs. So large amounts of materials are removed during mining, and it disturbs a lot of land. So land disturbance is huge in mining operations. The different mining methods are used to extract minerals. So depending on, like I said, what you are mining, you're going to have a different method. And it also depends on the economic efficiency. So strip mining is removing surface soil and rock. So this is the removal of the layers of soil and rock that are exposed, so that the resource is just below the surface. So here you're basically just removing the overburden, which is the soil and rock that is removed by heavy machinery. So it's just the top layer essentially. And then after extraction, each strip is refilled with the overburden. So this is kind of a good method because they restore the surface kind of as they go. There's not like a big reclamation project that has to occur once they're done mining. So this is usually for things like coal, oil sands, and sand and gravel. So strip mining is pretty common when we're doing sand and gravel for construction purposes. So this does cause some severe impacts because it completely changes the landscape. So it's good in a way because they don't have to do a big mining reclamation project at the end, but you're still completely destroying ecosystems and the way that the land was prior to mining. Subsurface mining is when we have access to deep pockets of mineral through tunnels and shafts that can go up to 2.5 miles deep. So this would be for things like zinc, lead, nickel, tin, gold, diamonds. You find a much smaller quantity, but it's worth more than like sand and gravel would be. This is the most dangerous form of mining because you can have collapsed tunnels, you can have a lot of toxic fumes in the shafts. And if you don't have proper ventilation, you can lose oxygen. And any collapsed tunnels can obviously kill miners and have an environmental impact as well. Acid drainage is sulfide in newly exposed rock reacts with oxygen and rainwater. So this produces something called sulfuric acid. And this can leach toxic materials from rock. So no matter what type of mining you're doing, acid drainage is a possibility. And this can flow into streams and kill fish and other organisms. This can pollute the groundwater that we use for drinking and irrigation. So although acid drainage is somewhat natural, mining accelerates this and exposes new rock at the surface at once that was previously buried. So this can mining can kind of accelerate acid drainage if they're not careful. So open pit mining is another type of mining that you've probably seen. This is basically when they dig everything out. It creates these huge holes in the landscape, and it's usually used with evenly distributed minerals. So we terrace everything, so we kind of make little benches or ledges as we go down so that men and machines can go in and out. Usually these are copper, iron, gold, diamond, coal mines, and we call these quarries. They are open pits for clay, gravel, sand, stone. They remove a huge amount of rock and soil to get a very limited amount of minerals out. Here we see a lot of habitat loss, aesthetic degradation, so it doesn't look as nice as it used to. There is acid drainage, and then they usually just abandon the pits and oftentimes fill it with water, which isn't necessarily a good thing because if there's a lot of water in these areas that have now been exposed and created acid drainage, all of that water is then contaminated, and then it's contaminating soil and further contaminating groundwater and surface water. So this is the world's largest open pit mine. It's in Utah. So this Utah mine is 2.5 miles across and almost a whole mile deep. And it's about 500,000 tons of rock and ore is removed every day. That is a lot. Oh, and it's a copper mine. So they're mining for copper. You can see some of the copper residue at the bottom there. So placer mining is another type of mining that they use running water. So using running water, miners can sift through materials in riverbeds. So this was very common in gold mining or mining for other gems. The debris that is left behind is washed into streams, and they can be uninhabitable for wildlife. This disrupts the stream banks, and it causes excessive erosion, and it harms the plant communities. So although it seems like it would be low impact, and it would be if it was one or two people kind of doing it, but when you have these large operations alongside of a river, it can be very impactful to that habitat. Mountain removal and reshaping ridges. So sometimes entire mountaintops are blasted off, and we call this process valley filling by dumping the rock and debris into valleys. So for coal in the Appalachian Mountains in the United States, this is the process that they use. They completely remove the mountain. And this degrades and destroys vast areas. This pollutes streams, deforests areas, causes erosion, causes mudslides, flash floods, biodiversity loss, and pretty much just devastates a particular area. So an area the size of Delaware has already been removed in the Appalachian Mountains just looking for coal. Or just mining coal, I should say. So again, this is very devastating because we are blasting entire mountaintops off, and it cracks the foundation and the walls of the remaining mountain. So this can cause weakening of that mountain, and then you're going to get more landslides, rock falls, things like that after you have blasted the top of a mountain off. The coal dust and contaminated water can cause illness. We see lung cancer, heart and kidney disease, pulmonary disorders, hypertension, and death in certain instances. And the poor people of the Appalachia suffer while the benefit goes to the coal-produced operations. So the miners actually make a lot of money, and then all of the people that live in the area are the ones that are left with, the devastating loss of habitat, aesthetic, and, life. So critics argue that valley filling violates the Clean Water Act. In 2010, the EPA introduced rules to limit the damage. So luckily, in the last 11 years or so, we've seen less mountaintop removal, just because the EPA has put higher regulations on their operations, and they can't do as much as they used to. So the solution mining dissolves resources. So solution mining is in situ recovery. So this is resources in a deep deposit are dissolved in a liquid and then sucked out. So things like water, acid, and other liquids are injected into holes. This is used for things like salt, lithium, boron, bromine, magnesium, potash, copper, and uranium. This has a less environmental impact than other methods because less surface area is disturbed. But we do see acids, heavy metals, uranium that can still leak or leach out of rocks and contaminate groundwater, which is not good. Ocean mining also exists. This is when we extract minerals like magnesium from seawater. Minerals are dredged from the ocean floor. And then we have these things called manganese nodules, which are small ball-shaped ores that are scattered across the ocean floor. And these reserves may exceed all terrestrial reserves, so they can be very economical. And the logistical difficulties in mining have kept extractions limited so far. So although these reserves can prove to have a much higher economic value, the mining logistics are just so difficult, it's really hard to do. So there hasn't been as much ocean mining as terrestrial mining. So restoring mine sites only partly works. So there's something called reclamation, which is basically bringing a previous mining site similar to its pre-mining conditions. And this can be done under something called the U.S. Surface Mining Control and Reclamation Act in 1977. This mandates restoration. So companies must post bonds to cover restoration costs. So when you are setting up a project or a mining operation, you have to include reclamation costs in your budget. And you have to have a reclamation plan. And if you're interested, I can show you an example of one that I did for a mining reclamation course. But you basically have to have a plan to restore the lands to something that's similar to the way it looked prior to mining. And this doesn't just include like filling the hole in. This includes revegetating the area, what kind of plants will work in the revegetation, when you're going to revegetate, when you would seed, things like that. So there's a lot that goes into reclamation. This includes filling any shafts that are open, filling any holes, like open pits that are open, removing any tailings piles, restoring any streams that may be nearby. It is huge. It's a huge project. So this is really important because it helps kind of recreate the land that used to be there. So even on restored sites, impacts can still be severe and long-lasting. Complex communities are simplified, so forests, wetlands are just replaced by grasses. So depending on the area, sometimes they're just like, let's just put some grass there, which is oversimplifying, what type of restoration is needed. So water can still be reclaimed. We need to moderate the pH and remove any heavy metals because all of those things can have long-lasting impacts on our surface water and groundwater. So there's something called the General Mining Act of 1872, which encourages metal and mineral mining on federal land. So any citizen or company can stake a claim or buy basically $5 per acre any public land open to mining, and the public gets no payment for any minerals found. So supporters say it encourages a domestic industry that is risky and requires investment to local vital resources. And critics also say that valuable public land basically free to private investors, and then people have developed the land to have nothing to do with mining. And efforts to amend the act have failed in Congress. So obviously this is an 1800s act that everybody that's more environmentally conscious today is trying to kind of fix and make it better. Make mining still exists because we do need the resources, but make it so that it has less impact on the environment. So minerals are non-renewable, as we've discussed, and they are scarce. So many minerals are rare and could become unavailable. Once known reserves are mined, minerals will be gone. So for example, indium used in LCD screens might last only 32 more years. But as you've kind of noticed that with new discoveries and new technologies, consumption patterns, recycling minerals, we kind of come up with other ideas or other ways to make things. So as minerals become scarcer, prices will rise. So for particular minerals, here's kind of a look at how many years we might have left. So for lead, we have quite a bit of time, 350, almost 400 years left. But when we look at things like nickel, we might only have less than 100 years left of what is, available as resources because they are, as I said, non-renewable. But we can use them sustainably. So as a theme in this class, sustainability, sustainability, sustainability. So we can recycle minerals because we have these finite supplies and because we want to cause less environmental damage. So 35% of metals were recycled in 2009 from US solid waste, and 35% of our copper comes from recycled sources, which is really awesome. Recycling decreases the energy use as well, so we have a lower greenhouse gas emission. And aluminum from raw sources uses 20 times more energy than from recycled sources, which is amazing. So recycle your cans, please. And we can recycle metals from e-waste. So e-waste is electronic waste from computers, printers, cell phones. And this is rapidly rising because people previously didn't have laptops and things to get rid of. But now that, technology is moving forward and we have, 15, 20 years of people having an actual laptop or computer in their home, those are now being turned in and recycled, and we can get different things out of them, and we can recycle them. And it keeps hazardous waste out of landfills while conserving mineral resources. So cell phones can be refurbished and resold in developing countries, or other parts can be dismantled and refurbished. Today, only 10% of cell phones are recycled. So recycle your cell phones, please. Recycling reduces the demand for virgin ores and reduces pressure on ecosystems. So in conclusion, we have the geologic processes that shape the Earth's terrain, and they form the foundation for our living systems. So we depend on the minerals and metals to make our products that are from geologic rocks or mineral ores. And mineral resources are mined by various methods, and they contribute to material wealth, but they can cause extensive environmental damage like habitat loss, acid drainage, groundwater contamination, etc. And the restoration and regulations help minimize these environmental and social impacts of mining, but recycling and sustainable use will help us prolong these mineral resources and have less environmental damage. And that's it for this PowerPoint. I will see you guys in the next one. Bye.